Welcome to Intro to Mechatronics Part 6. In this video, we'll be going over how to program count-ups in ladder logic to count how many donuts are on an assembly line so that every 13th donut gets sent to the test lab. So to begin, let's go over the anatomy of a count-up operation, abbreviated CTU in Allen Bradley format. First, we have the field that is the counter name, which is used to reference the counter elsewhere in the program. Next, we have the preset value, which is the value the counter is at a done state. Done is reported if the accumulated value is greater than or equal to this value. And finally, we have a field that is the accumulated count, or how many times a false to true signal is registered. For your reference, we can use the counter name and a .acc for referencing the accumulated value of the counter, and the counter name with a .dn for indicating when the counter has reached its preset value. We will also be using a res function which resets the accumulated value and the counter.done bit. Our input will be a counter sensor which is true or on when a donut passes through the sensor beam. And our output will be a test sample indicator which we want to be energized once a sensor senses the 13th donut passing through the sensor. Okay, so I've given you everything that you need to complete the ladder diagram program. You may want to pause here and try it out for yourself. Also, for your reference, here's a slide that goes over the basics of ladder logic and types of contacts and energizers. So I want to lead with there are multiple ways to skin a catfish. The way I decided to complete this is by using a normally open contact that is connected to a sensor so that it completes and closes the circuit every time a donut passes through the sensor beam. This true or on signal is then sent to the count-up, which I named donut num, and set the preset value to 13. This means that once it reaches 13 donuts, it will report a done signal. The next rung, I put a normally open contact that is tied to donut num counter being done by using a donut num.done. This then goes to the test sample energizer, which turns on the machinery to separate and send to the test lab. Then on the final rung, I have that when the true or on signal is sent to the machine, it also sends a signal to the third rung, which resets the counter value to 0 so that the whole process can repeat. To finish off this video, I will quickly go through the process of counting out a baker's dozen so that you can see how the program works. First donut is registered, which causes a true signal to be sent to the counter. The accumulated value increases by 1 in the counter. The donut then passes completely through the sensor beam, and a false or off signal is registered. The same process repeats up until the 13th donut is reached. At this point, the counter reaches the preset value and reports a done signal to the second rung. This energizes the coil and sets in motion the process to get the donut separated and sent to the test lab. This also energizes the third rung, which then resets the value of the donut num counter to 0. Then the process repeats. Well, I think it's time for me to get a donut. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Let me know how I'm doing in the comments down below. Thank you for watching. Also note, I created a poll on my community tab on this channel, which for every vote in a specific topic, I will create one video in that topic. So be sure to vote.